This video is on the second exponent rule, power of a power. Again, we're going to look at examples and then we're going to try to figure out what the pattern is from those examples. So here is the first example that we're going to look at, and again, this is a continuation of the Core Plus book. We're on page 305 now, and it's titled Power of a Power. So in A, we have 2 to the third power to the fourth power, and we're going to focus on this portion first. 2 to the third power, and 2 to the third power can be written as 2 times 2 times 2, and then this piece is to the fourth power. So at first, the base is 2, the power is 3, and that's our focus. So the 3 tells us to write the base of 2 3 times. Then we move out a level, and we see that this is now the base, 2 to the third, and the 4 is the power or the exponent. So that means that this piece, this base, needs to be written out 4 times with a multiplication sign in between. So we have 2 times 2 times 2. That's multiplied by 2 times 2 times 2. We write it again, and we write it one more time. So 4 times we wrote it out. Now let's total how many bases of 2 we have now. So if we use 2 as our base, let's count out how many we have. So we have 3, 6, 9, we have 12. So 2 to the third power to the fourth power is the same as 2 to the 12th power. So z is equal to 12. Let's look at B. So we have something similar to what we just had in A. We have 3 to the fifth power, so we can write that as 3 times 3 times 3 times 3 times 3. And then this base of 3 to the fifth is supposed to be written out 2 times. So in total, we write this base of 3 5 times, 10 times. So 3 to the fifth power, 3 to the fifth power, which is represented here, to the second power is equal to 3 to the 10th power. So z is equal to 10. Okay, example C. In this case, we're not told what x is, but we need to figure it out. So again, we're trying to figure out what this pattern is. So if I write 5 times 5, which is 5 squared, to some power, it needs to be equal to 5, the base of 5 written out, 6 times. 1, 2, 3, 4, 5, 6. So here, if we have 2 5s, we have 1, 2, 3 sets of 5 squared. So I could write this as 5 squared to the third power. So I would write this set of 5 squared 1, 2, 3 times to get 5 to the 6th power. So x is equal to 3 in this example. In D, now we have a variable b, and we write out b, the base of b, 2 times. And then this base, the base of 5 squared, is written out 5 times. And then I'm going to add one more over here so that it fits better. So we wrote it out 1, 2, 3, 4, 5 times. So in total, we have 2, 4, 6, 8, 10 b's written out. So we have b to the power of 10. So the base is b, the power is 10. So in this case, z is equal to 10. Now I want you to think about the pattern that you saw over and over again, what's going on. Please pause the video and write out what b to the power of n to the power of n is equivalent to. Hopefully you've taken that time to yourself. And the quantity b to the power of m to the power of n is equal to b to the power of m times n. And what's important to remember is that whatever is here is multiplied by what is on the outside. Okay, so it's different than the first rule where you add them up. The first rule, you will notice, in between the exponents, we have a number or we have some variable. In this rule, the only thing that comes between the m and the n is this parentheses mark. So people often get that rule confused. When do I add? When do I multiply? You multiply when there's just this one piece, this one parentheses in between the m and the n. Here you add when you have a base in between the two exponents. So make sure you keep the two rules separated in your mind. So that was rule 2. I will do rule 3 in the next video.